Basically like to study the Caesar cipher. So today we will be studying the Caesar cipher that we have in cryptography. The Caesar cipher. So today we will be studying the Caesar cipher that we have in cryptography. So basically how a Caesar cipher works is that Caesar cipher is first of all it's a symmetric key cipher, which does mean that it uses the same key for encryption and it uses the same key for decryption as well. Right. So it is a symmetric key cipher, and its property is that it's a substitution cipher. Substitution cipher. Now, what does a substitution cipher mean? A substitution cipher means that if we have a particular plain text, right, say hello. So if we have a particular plain text, so every character in this plain text will be substituted by some other character. So it is a substitution cipher. And substitution ciphers are also divided into like mono and poly alphabetic substitution ciphers. So this one will be a mono alphabetic substitution cipher. So here we have an L. So let's say if this L is substituted by a letter J, so the next L it will be substituted by the same letter J. So it's a one-to-one correspondence. So one character will always map to one a single character. Like in a particular string, they cannot be that the same characters are substituted by different characters, right? So in a mono alphabetic substitution cipher, so basically how a scissor cipher works is that we can see the indexes of each character. So we have 26 characters in English language, and if we trace like each character, if we write, so each character in this will have a particular index, right? So here we can assign a an index of 0, so it is 0 based index, right? It is a 0 based index. So if 0 is a is assigned an index 0 and b will assign an index 1, right? And c will be assigned an index 2. So if we further continue assigning these all, so now that I've assigned all of this value to these different characters in English alphabet, so basically for encryption in Caesar cipher, what we need to do is that here we have the formula for encryption. So the index of the encrypted character will be the index of the plain text character plus the shift that we'll be having, and we will take a modulus with 26 here. And for the plain text, if you want to find the plain text by a given ciphertext, so we can write this formula as plain text will be the encrypted text, encrypted character index minus the shift, and we will take the modulus with 26. So if now we have to consider, so if now we are gonna consider an example, right? So we will be considering an example. So if we are about to consider the plain text, let's say hello. So we are going to consider a very simple plain text hello. So let us say that here we have a plain text which is said as hello, and let us say we have a shift of 4. So what happens in a Caesar cipher is that so in a Caesar cipher, what happens in a Caesar cipher is that if we consider this mapping, so if we have a plain text of hello, and if we consider a key shift of, let's say, if we consider a key shift of like 4, so basically each character in this will be shifted by 4 positions. So in this we can see the index of h is 7. So if we shift by 4, like 4 positions from h, we will get the letter k. So we know that h will be mapped to the letter L, the letter L, right? So E will be mapped to, from here we can see E will be mapped to 4 positions in front of it. It will be F, G, H, and I. It will be like I. So E will be mapped to I, and L will be mapped to like four positions in front of it, right? So it will be mapped to P. L will again be mapped to P, and O will be mapped to, or we can say O will be mapped to the position 2, 3, 4. It will be mapped to the T. So finally we will get the encrypted text as this. So if we try to do this from our formula, we can say, so plain text, we will say like encrypted text or cipher text for a particular index will be like plain text index plus shift modulus 26. So here we have like for hello, for H we have a plain text index is 7 and the shift is 4. If we will find its value, right, then it will be 11 modulus 26, which will be 11. So the 11th character or the character with the 11th index will be substituted with H. So for ciphertext H, we will get a plain text L. So similarly, we can find each mapping. Now let us consider the case of decryption, right? So let us say that we have been given this particular encrypted text, and what we need to find is that we need to find the find particular plain text out of this encrypted text, and let us say that we have been given a key 4. So as I told you, the formula for the getting plain text back is the encrypted index minus the shift modulus with 26. So let's say that for L we have the index as 11. So we will minus the shift with it 4. And we will get a value of 7. So which does mean that for plain text index for a character L, which is from the ciphertext, the corresponding character in the plain text will be the character which is at the 7th index, which will be the ladder H. And similarly, we can find for all of this, and it will be correspond to this plain text. And in any case, if this value becomes negative, right? If this becomes negative, then we have to add 26 in it for it to become positive. Then we need to like map the characters.